what do you see as the most effective design, material topology implementation to reduce losses in permanent magnet motors?
That's a fun question. So in terms of topologies, and where I end up playing a lot is people trying to push that power density formulation, as much as they can. A lot of people obviously go with a PM, design configuration for that. And what we do from a topology standpoint, it's not a new technology / new configuration or topology, but a lot of people are starting to look at things like you said, they might cost a little bit more, but they're really trying to squeeze these power densities. So people are squeezing power densities with starting to become much more common again, is what's called a Halbach array configuration for a surface mount permanent magnet system. And that just gives you a little bit more of that power density. Yes, it is more complex. It takes more time to assemble. There's more SKU numbers. So it does drive, cost into the system. But that is one kind of topology that we see with the surface mount system that is coming about. We're starting to see more. Other people are just pressing the materials technologies, I think, to their absolute limit. We see that with thin laminations. So if I'm not going to use something that saturates at a higher flux density, like a cobalt lamination steel, if I'm looking at a regular no-go steel, it's how thin can I make that steel to reduce those losses, those heat losses and eddy current losses. In the presentation just before ours, I was kind of watching the recap of that, and it's, how do we get the heat out? How do we stop making so much heat to make these more efficient, and how do we, heat is the enemy, right? Because it starts degrading your magnets, etc. So long-winded answer for your question of kind of what do we see from a topology configuration, but I'd say one of the biggest things we're seeing now is a Halbach array configuration on a surface mount system.